In this video, we're going to have a look at how we can create spline shapes in Cinema 4D. If you do an internet search, you will find a ton of tutorials on this subject, but almost all of them have one thing in common. They use Illustrator files that are imported into Cinema 4D and then extruded. Well, that's not really creating spline shapes in Cinema 4D. So in this tutorial, we're going to use only the Cinema 4D spline tools to create nice looking spline shapes. I'm assuming that you have a basic knowledge of Cinema 4D, and you will need at least release 17 to be able to follow along, because in release 17 the spline tools have changed quite a bit and there's a lot of stuff that you can't do in older versions of Cinema 4D. As a first example, we're going to do a jigsaw puzzle. And you might be thinking, well, this looks like a very complicated piece, but it actually isn't. You can do something like this in about 15 to 20 minutes. The tutorial will take quite a bit longer because I have to explain a few things, but essentially this is not a very difficult piece to do. So let's get started. First of all, we need a reference image. So I'm going to switch to the front view and I'm going to drag in the reference image from the Windows Explorer into the viewport. Now let's go to Options, Configure, and here on the back tab I can change the size, and I'll make this 1500 to make this nice and big, and also I'm going to change the transparency a bit so we can see our splines a little better. Let's have a look at this image. What we have is two different puzzle pieces that are copied around a circle a number of times. So I guess the obvious thing to do would be to trace each of these puzzle pieces using the pen tool and then to copy those pieces around. However, that would not be a good idea. The main problem is accuracy and consistency. So you'll probably find that if you create one of these pieces, it will look fine, but as soon as you start putting the pieces together, you will probably find that this line on the outside, for example, which is supposed to be a circle, is not really consistent. You will probably get slight bumps where the pieces meet. Another problem is these openings and the protrusions. These all look like they have the same shape and size. And again, it's quite difficult to get the shapes and sizes consistent if you trace these puzzle pieces manually. Also, we need an even width for those gaps, and we need to make the puzzle pieces fit together in this area here. And of course, this is doable. You can do this by tracing the puzzle pieces manually, but it'll take more time and it's more difficult to get the shape to look right. So that's not what we're going to do. Let's pretend for a minute that we don't have these openings or the protrusions here and here. What is left is a circle on the outside and a circle on the inside. So basically we have a ring, and that is the basic shape of this jigsaw puzzle. So a good idea would probably be to start with a circle. So I'm going to add one to the scene, and I'm going to change the radius and match this up with the reference image. And in order to create that inner circle, we can use the ring option here. So let's check that, and that will add a smaller circle here at the center, and we can change the radius of this circle and match that up with the reference image too. Next, I want to create those gaps, and these gaps consist of a line and this protrusion here. And like I said earlier, this circular shape here is the same as the shape of this opening here, and it is also the same shape as the one of the protrusions here. So what I want to do first is I want to create a template for this shape here that we can use for the openings and for the protrusions. Since this shape is basically circular, I'm not going to draw this manually, but I'm going to use another circle spline as a starting point to create our template. And I'm going to move this circle spline up to about here, and let's change the radius and make this a lot smaller. And in order to create this opening up here, we're going to combine this circle spline with a rectangle spline. So let's go ahead and add a rectangle spline to the scene, and I'm also going to move this up to about here, and I'm going to scale this down quite a bit to about here. And in order to combine these two objects, we're going to use a spline mask object. And let's make the circle and the rectangle children of that spline mask object. By default, this object is set to union, which in this case is exactly what we need. Right now we're not going to worry about the fact that we have a nice and round corner here. That is a detail that we're going to add when everything else is done. So our template is basically finished, so I'm going to rename this to hole/protrusion template, and I'm going to center the object axis on the spline mask object, and we can do that by going to Mesh, Axis Center, bring up Axis Center, and we can use the default settings here, but we have to check Include Children and use all objects. So now we can use this template as a starting point for creating the next object, which will be the gaps. And in order to make modeling those gaps a little bit easier, I'm going to rotate the reference image a little bit. So let's hit Shift V to go back to our viewport settings, and on the back tab we can change the rotation of the reference image, and I'm going to bring this down to -22.5 degrees. Let's make a copy of our template. I'm going to make the original invisible and rename this to gap, and I'm going to rotate the gap -90 degrees, and I'm going to reset the object axis. We can do that by enabling axis, setting this number here to 0, and switching off enable axis again. And now we can move this around and line it up with the reference image. And right now we can't use the spline mask object as it is because it combines the circle and the rectangle, but we need to be able to continue this line here. So let's change the mode of the spline mask object from union to A subtract B. Also, this circle is curving in a little bit too much, and we need to make this circle follow this line a little better. So what we can do is select the rectangle tool and change the width to maybe about here. I'm using the bottom of this protrusion here as a guide. So this looks pretty good. And now we can make this spline mask object editable. Go to point mode, and I'm using the rectangle selection tool to select these 2 points and delete them. In order to be able to continue this outline here, we have to get an opening here. And we can do that by selecting either this point up here or this point down here, and then changing some settings. So let's select this point up here, and let's right click and set this as the first point and see what happens. Nothing happens because we also have to select the spline and uncheck Close Spline. So you can see we're getting an opening, but it's not where it should be. Now if this happens, you don't have to select the other point and try again. What we can do is reverse the sequence first and then set this as the first point. And now we have the opening where we need it to be. Because this gap is symmetrical top to bottom, we're only going to create 1/2 of this gap. So in this case, I'm going to select the top points here and I'm going to delete them. And in order to be able to continue this line, we're going to select this point here, and then we're going to select the pen tool. And because we've selected this point, we're immediately getting this line that is attached to this point. And all we have to do now is to create one more point. And I want to create this below the inner circle. The reason is because we have to make this object intersect with this circle in order to be able to subtract the gap from that circle later. So let's left click and drag, and I'm just going to line up the tangent here at the top roughly with the center of this black line in the reference image. I also want to get rid of the bottom handle. In this case, that's not really important, but it gives me an excuse to show you a few things. So let's hold down Shift, left click and drag on this handle and just make it smaller. And now I'm going to switch to my Move tool. And when you have the Move, Scale or Rotate tool selected, you can double click on a point and open this window here, which says Values and Tangents. And the reason I made this bottom tangent smaller is because if both of these tangents have the same length, I can never tell them apart. So by making this smaller, I know that the smaller numbers refer to the smaller tangents. So in this case, we'll get rid of the right tangent, which is the bottom one. So now we've created a very rough outline of the shape we need. In the next video, we're going to learn how we can tweak spline points and get the shape that we want. Before we do anything else, I want to add a little more transparency to that background image because it still seems a little bit bright. Also, I want to select this point here, and you can see it only has one tangent. This point was created when we subtracted the rectangle spline from the circle spline. Right now we have a sharp corner here, and that's not very useful because we need to create this round shape. So we need the second tangent, and you can easily add that by selecting the point and then right clicking and selecting equal tangent length. And this will create the second tangent, which will be parallel to the first tangent, and it will have the exact same length as the first tangent. In this video, we're going to talk about how we can modify tangents on spline points. And there's two ways you can do that. One is by using the Move, Scale or Rotate tools, and the other way is by using the Pen tool. And in this video, we're going to have a look at how we can modify tangents on spline points using the Move, Scale or Rotate tools. When using Move, Scale or Rotate, there's two important things to remember. One, you have to make sure that you only have your spline selected. If I select an additional object here and then select a point and I'm trying to modify the tangents here, what happens is that I will move the point and I can't tweak the tangents. So make sure you only have your spline selected. The other thing to remember is that you can only have one spline point selected at a time if you want to tweak the tangents. If I select 2 points here and I try to tweak the tangents up here, what happens is something like this. You can see I have no control over what I'm doing really. And this is bad news because actually it's very helpful to be able to have more than one point selected and to quickly change the tangents on one point and then change the tangents on this point up here without having to reselect the points all the time. The good news is we can have more than one point selected on a spline if we use the Pen tool to modify tangents. So make sure you only have one point selected when you use the Move, Scale or Rotate tools. The tangents can be changed quite easily by just left clicking and dragging on either of these tangents, and you can change the length and the rotation of these tangents. By just left clicking on a tangent, you will always change both tangents. In this case, that's not really what we want, because we have this perfect curve up here. We don't want to change that. So we would only want to tweak this tangent here. And you can do that by breaking the tangents. And you can do that by holding down the Shift key and left clicking and dragging on the tangent that you want to modify. And you can see I can now change the length and rotation of this tangent here. Now the problem with doing that is that it is virtually impossible to keep this tangent here parallel to this tangent. However, on a curved shape like this, it is really important that these tangents always stay parallel to each other. Because if I change this tangent here, and I'm exaggerating a little bit, if it's not parallel to the other tangent, you will create a corner. We can fix that by right-clicking and selecting equal tangent direction to make sure that these tangents are parallel again. So let's see what happens if we select this option here. In this case, you can see the tangent that we modified is lined up with the second tangent here. So that's perfect because we haven't changed the curve up here. However, there is one thing to remember here. It is not always the tangent that you modify that gets lined up with the other tangent by using equal tangent direction. The tangent that is made parallel to the other tangent is the one that is facing towards the end of the spline. And if you take a look at this spline, you can see we have a color that goes from white to blue. White being the start of the spline and blue being the end of the spline. And that's the reason why, in this case, the tangent that we modified was the one that got aligned to the other tangent. If I go back a step and right click and reverse the sequence of the spline, we now have the start of the spline down here and the end up here. And if I select equal tangent direction now, what happens is that the bottom tangent gets aligned to the tangent that we modified, and that is not what we want because this destroys the shape up here. So if this happens, just go back a step, reverse the sequence of the spline, and then use equal tangent direction. So let's go back a few steps. On points that only have one tangent, like the one down here, you don't really need to worry about tangent directions. You can simply left click on this tangent and change the length and rotation. And we don't have to hold down the Shift key when we have a point that only has one tangent. Sometimes it's also useful to use the scale tool for changing tangents on spline points. If I select this point here and I now have my scale tool selected, I can simply left click and drag in the viewport to scale the tangents. The nice thing about this is that we don't accidentally change the rotation of the tangents. However, you can only change both tangents simultaneously, and there's no way to scale just one of these tangents. If you left click and drag on one of the tangents, you will modify the tangent as if using the move tool. So that's one thing to remember here. And again, on spline points that only have one tangent, we don't really have to worry about changing two tangents because we only have one. So in this case, I could maybe use the move tool and line this point down here up a little better, adjust the rotation of the tangent, and then switch to the scale tool. And I could scale this tangent up and try to get close to the shape that we need. The rotate tool is not as useful, but spline tangents can be tweaked using the rotate tool. And like with the scale tool, you don't want to left click and drag on the tangents, but instead you want to use the gizmo to rotate the tangents like this. And you can hold down the shift key to rotate those tangents in increments of 10 degrees. So this is all you need to know about tweaking tangents on spline points using the Move, Scale and Rotate tools. In the next video we're going to have a look at how we can use the Pen tool to modify tangents on spline points. In this video we're going to have a look at how we can modify spline tangents using the Pen tool. So let's select the Pen tool, and I'm going to select this point here. And now we can left click on one of the tangents and drag. And this is pretty much how the Move tool works, with one exception. You can see that we're only changing the length of one of these tangents. However, we're changing the rotation of both of the tangents. One option we have with the Pen tool that we don't have with the Move tool is that we can have more than one spline point selected. So if I select both of these spline points, I can still tweak the tangents on each of these points without getting the erratic behavior that we experienced when using the Move tool. And of course, when tweaking tangents, you can also hold down the shift key and break the tangents to modify only one of the tangents. And you can see we're getting the same problem that we had with the Move tool. The tangents are no longer parallel to each other. So we can use equal tangent direction to fix that. Now let's have a look at a couple of more options that we have with the Pen tool. You can see all of the options down here in the Attributes Manager, and we're going to talk about each of these quickly. By default, the type is set to Bezier, and this is the type you want to use if you draw or trace curved shapes like this one. The other important type is Linear. You can use Linear to draw blueprints for a building, for example. The other spline types that we have here are really not very useful for drawing accurate shapes, so we're going to ignore these. The next option we have is Edit Tangents mode. And what this does is it locks the position of all of the points on a spline, and it doesn't matter if they're selected or not. Usually if I want to move a point around, I would left click and drag to change the position of the point. If I want to prevent that from happening accidentally, I can check Edit Tangents mode. And now if I left click and drag on a point, I can't move it. What happens is that I immediately start modifying the tangents. The next option we have is the most important one and the most useful one. It's called Lock Tangent Rotation, and if I check that, I can select this point here, and I can left click and drag on this tangent. I can even move my mouse away from the tangent, and all I can do is change the length of this tangent but not the rotation. So this is very useful because it allows me to accurately and easily modify individual tangents on spline points. And we don't have to worry about changing the rotation or about the tangents not being parallel to each other. The next option we have is Lock Tangent Length, and if I check that, I cannot change the length of the tangents anymore, but only the rotation. And if I left click and drag, I will change the rotation of both tangents. I can hold down the shift key and only change the rotation of one of the tangents, but I still can't change the length. The last option we have is Create New Splines. If you have a spline selected and you're in point mode, you can create a new shape that is not connected to the original spline, but it's still part of the original spline. You can see here in the Object Manager that we're not creating a new object. So it's still a single spline, but we have shapes that are not connected to each other. If you want to create a new spline, when you do that, you have to check Create New Splines. Now this will only work if you don't have one of the endpoints on the spline selected. If I select an endpoint here, you can see we're getting a connection to the pen tool. And even though this option is checked, we will continue this shape here and we will not create a new spline. So if I deselect all the points here, I can now draw a new shape, and you can see in the object manager that we're getting a new spline. If we want to, we can connect this spline to the original spline by left clicking on one of the endpoints. And now the two splines have been combined, the sequence has been reversed, and we are connected to the endpoint on the spline, and we can continue drawing the shape from here. You can also check combinations of these options. For example, if I don't want to move the points accidentally, I could check Edit Tangents mode, and I could also have Lock Tangent Rotation checked at the same time, and then tweak those tangents. Some of the combinations, however, do not make a lot of sense. For example, having Lock Tangent Rotation and Lock Tangent Length checked means that I cannot change the rotation or the length of the tangents. So that's not really very useful. What happens if I make this a little bit longer so we can see that? If I have both of these options checked, and if I left click and drag on one of the tangents, nothing really happens, because like I said, you can't change the length or the rotation. If you move your mouse over at some point, the tangents will be rotated 180 degrees. So now let's finish this spline shape. I'm going to use the pen tool, and I have Lock Tangent Rotation checked here. And what we can do is we can left click and drag on this tangent and maybe make this a little bit longer. And we could additionally select the point down here and tweak this tangent a bit. And obviously we have to rotate this tangent a bit, so I'm going to uncheck Lock Tangent Rotation. Now I can change both the length and the rotation of this tangent and line this up a little more accurately with the reference image. So I think the spline is now looking pretty nice, and in the next video I'm going to show you how we can test the spline shape to make sure it looks good, and then we'll continue and finish this gap spline. No matter how good a spline looks, you can only really tell if the shape is looking good if you extrude that spline and render the shape. So testing the spline shapes is an important part of my workflow to make sure that I get a nice looking shape. And in this case that's particularly important because we have to mirror this spline over to the top, and then we have to create a lot of copies. And I really don't want to find out at the very end, when all the pieces are finished, that something's wrong with those curves. The problem with our spline is that it is not a closed spline. We can extrude this spline by adding an extrude object, but you can see it is only extruded in the Z direction, which is not very helpful. So let's select the spline, and I'm going to hit Q. If you have the spline or the extrude object selected, you can use the Q key to toggle the extrude object on and off. So what I usually do with a spline like this is, first of all, I check Close Spline down here in the Attributes Manager. And that is not very helpful yet, because if I extrude it and render it, we can't really see the outline because we're getting a connection straight from the end point to the start point of the spline, and it cuts right through our spline shape. what we have to do is create an additional point on this line, and we can use the move scale or rotate tools or the pen tool to create an extra point here. And the way you do this is you hold down Control if you use the move scale or rotate tools, and the cursor will change to an arrow with some dots. And now we can left click anywhere on this line to create a new point. The pen tool works pretty much the same way. So if I select the pen tool and hold down Control, the cursor will change to this horizontal line, and now I can left click anywhere on this line to create a new point. And now we can left click on the point and move it over somewhere to here. And now we have a shape that we can extrude. So if I switch on the extrude object and render this, we can now see the outline of our spline shape. If I get a little closer, you can see the spline looks quite faceted, and that is because of the settings for the spline resolution. If I select the spline, you can see down here the type is Bezier, and we have intermediate points that are set to adaptive. Adaptive means that Cinema 4D will create more points on curved sections on a spline to make those curved sections look round and smooth. And if you have a straight section, you don't get any intermediate points because 2 points are sufficient to define a straight line, so it doesn't make any sense to add any additional points in between the start point of a straight section and the end point of a straight section. So for a curved shape like this, adaptive is usually the setting that you want to use, because you're only getting points or more points in those areas where those points are actually needed. The resolution of the spline, or the detail or the smoothness of the curves, is defined by the angle of the spline. The default is 5 degrees, and if I increase this angle, our spline will look more faceted. In order to test your spline shape, it is sometimes helpful to add more resolution to the spline to make it look very smooth. So you can focus on the areas that may need tweaking without getting distracted by the fact that everything's looking a bit faceted. So in this case, I would decrease the angle all the way to 0 to get the maximum detail. And now we have something that is perfectly smooth. So let's see what we could tweak here. What I don't really like is the transition between this curve here and this curve up here. It could be a little smoother. So I think what I'm going to do is I'm going to add an extra point. I think this point here should be moved a little further down to here, but I don't want to move it manually because this will change the shape over here as well. What I'm going to do instead is I'm going to hold down Control and I'm going to create another point somewhere around here. Before I do though, I will make a copy of our spline. We can use this as a reference to tweak the new point we're going to create. So hold down Control and maybe add a point here. And now we can select the original point and delete it. So you can see the shape stays intact here, and we're only changing the shape here. So now what we can do is select the point, select the pen tool again to bring up the options here, and I'm going to lock the tangent length, and I'm going to rotate the tangents here just a little bit. And then we can uncheck lock tangent length and check lock tangent rotation instead, and left click and drag on this tangent and drag it out until we get a transition into this line here. So let's see, so something like this, and this should give us a much better transition between this curve here and this curve here. If I render this, or maybe I should switch on the extrude first. So you can see we're getting a much nicer transition between these two curves now. So now the shape is looking exactly like we want it to look. And now we can select the point that we created earlier, delete this point, select the spline, and uncheck close spline. And we can delete the copy because we don't need that anymore. So now we can be sure that our spline shape is looking exactly like we want it to look. And now we can continue and finish this shape. In order to create the gaps between the puzzle pieces, we can use a feature in Cinema 4D called Create Outline. If you right-click in the viewport, you can select Create Outline from the context menu. And all we need to do is left-click in the viewport and drag. Now you can see that we're having a bit of a problem because we're not getting an even width for this outline along the length of the spline. And the reason for that is because Create Outline doesn't have enough information to create that even width for us. And that means we have to add an additional point. So let's undo this. I'm going to switch to my Move tool and I'm going to create one more point somewhere close to this curve here. So hold down Control and left click anywhere here to create this extra point. And now if we use Create Outline, we should get something a lot more even. So if I extrude this and render it, you can see everything's looking fine now. Of course, I don't want the outline to be that wide. So let's undo this, and I'm going to enter a distance here for the outline in the Attributes Manager. We could try the default of 5 centimeters, but this seems a little bit wide. So what I'm going to do is maybe use only 4 centimeters. And once you've hit apply, you can't really change the distance and get an update in the viewport. So if you don't like the distance, you have to go back a step, enter a different number. Let's try 4 and hit apply. So 4 is actually looking good. Before we can mirror this spline over to the top, there's a couple more things that we need to do. First of all, we need to make sure that our spline is open up here, because this is our mirror plane. And that should be easy enough. We just need to select the spline and uncheck Close Spline. The other thing we have to bear in mind is that both of these points here need to be at 0 on the y-axis, because this is our mirror plane, and in order to be able to mirror this spline properly, these points have to be at 0. So let's go ahead and check that. This point here, you can see it's at 0 on the y-axis. However, this one isn't. And there's a couple of ways we can fix that. Because the distance by which it is offset from 0 on the y-axis is so small, we could just simply zero this out, hit apply, and it's not going to change the shape of our spline here. The other way to do that, or one of the other ways we could do that, is we could use the knife tool. And I'm going to use the line cut tool here, and I have single line switched on. And we could snap the knife tool to this point and make a straight cut over here. Now, because snapping for the knife tool is not very accurate, I'm going to additionally switch on this snapping here. And this sometimes seems to help. So let's enable snapping, make sure that vertex snap is switched on, and now we can snap the knife tool to this point, hold down Shift, and create a straight cut over here. I'm going to switch to the Move tool and delete the top point here, and let's select this one, and you can see it's almost at 0 now. So I'm going to just change the number to 0 here, hit enter, and now the point is exactly where it should be. In order to mirror this spline over to the top, we could use the symmetry object, of course. So we'll have to change the mirror plane to XZ, and that's working fine. The problem is that we're going to use Spline Mask later to subtract this gap from the ring, and using symmetry inside a Spline Mask object won't work. And that means we have to make the symmetry object editable. The problem is, if we do that, we're also going to convert our spline. So let's make this editable, and if I select the spline, you can see we've created a ton of new points here. And what you see is the intermediate points that Cinema 4D creates depending on the angle that we have set for the spline resolution. So if I go back a few steps and select the spline, you can see the angle is set to maximum detail. If I bring that up to the default of 5% again and make the symmetry object editable, we're still getting a lot of points. Not as many as before, but still way too many. So using symmetry is not really an option here. The solution is pretty simple. All we have to do really is make a copy of this spline and then go to model mode and use rotate to rotate the copy minus 180 degrees. And now we can select both of these splines and use connect objects and delete to combine them into a single spline. Let's go back to point mode. What we have to do now is we have to weld some points together, because right now this spline seems like a single object, but the segments are still separate. So if I use my rectangle selection tool, for example, and I have only select visible elements unchecked here, and if I select these 2 points, you can see in the heads-up display we actually have 4 points here. So in order to fix this problem, we only have to select 2 of these points, and we can use the weld tool and just left click anywhere in the viewport to weld these points together. And you can see that we now only have 1 point here. Over here, the second point has been removed automatically, and now we have this opening here. So let's select our spline and use close spline, and we have our completed gap. In the next video, we're going to use spline mask to subtract the gap from the ring and create our basic puzzle pieces. So now that we've finished modeling the gap spline, we can change the rotation of the reference image back to 0. And I'm going to select the spline, switch to model mode, and in order to be able to rotate this into position, I'm going to move the object axis to the center of the Cinema 4D grid. So let's switch on enable axis and put the object axis to 0 on the grid. And now we can rotate the spline, and we need to rotate it 22.5 degrees. And again, I'm going to switch on enable axis and reset the rotation of the axis to 0 here. Now let's make a copy of this spline and rotate the copy minus 180 degrees. And I'm going to select both of these splines and turn them into a single spline. And next I'm going to use a cloner object to create the other copies. The cloner object needs to be changed to radial, and we don't need any radius here for the cloner object because the object axis of our spline is at the center of the Cinema 4D grid. So I'm going to change that to 0, and we only need 4 copies. Like the symmetry object, the cloner cannot be used inside a spline mask object. However, we can make it editable without converting the splines. So let's hit C on the keyboard to make the cloner object editable, and now we can select the 4 spline copies and combine these into a single spline. And next I'm going to add a spline mask object, and let's drag the circle and the gap spline in there. And in order to create the gaps in between the puzzle pieces, all we have to do now is change the mode of the spline mask object from union to A subtract B. And I'm going to make the spline mask object editable, and let's put this in the extrude object. We can delete this cloner null object here. And if I switch the extrude object on and render this, you can see that we have created nice and even gaps, the shapes are consistent, and the puzzle pieces fit together perfectly. In the next video, we're going to add the openings to this puzzle piece here. In this video we're going to create the openings for the puzzle piece up here. First of all, I want to rename our spline to basic puzzle pieces, and then we can select one of the points on this puzzle piece here and use select connected to select all of the points of this puzzle piece, and then we can right click and split these points off to create a new object, and this will be piece number 1. I'm also going to split off the second puzzle piece, so select a point, select connected points and split those points off to create piece number 2. I'm going to make these two invisible, and now let's take care of these openings. So we're going to use a copy of our template, and let's make this editable and copy it and rotate it around 180 degrees, and I'm going to move it down and put it into position. So I'm going to turn these two splines into a single spline, and then we can put our piece number 1 into a spline mask object, add the openings and change the mode of the spline mask object to A subtract B. And let's make this one editable, and let's take care of these corners now. One thing we can't do is use chamfer to get the round corners. If I select this point and use chamfer, what happens is that while we do get a rounded corner, we also change the shape up here. So that is something we definitely don't want to happen. There is a very easy way to deal with corners like this. We can use the knife tool, and I'm going to use the line cut tool here and create a cut. And for the top, I want the point to be fairly close to this corner, so let's maybe put this here, and the point at the bottom we're going to relocate from its original position to maybe here. So now we can delete these 2 points, and you can see we haven't changed the shapes up here and down here, and all we have to do now is tweak the tangents on these 2 points to get our round corner. So let's switch to the pen tool and lock the tangent rotation, and we can make this tangent down here a little bit longer and drag this one out a little bit. So let's test our shape, and I'm going to increase the spline resolution so we're getting a nice and smooth render, and this is looking pretty good, I think. So you can see it was very simple to get this corner without doing a lot of work. And we're going to use the same technique on the corner down here. So once again I'm going to make a cut maybe from here to about here. I'm going to delete these 2 points and select these 2 and change the tangents to get our rounded corner. Okay, so that's looking pretty good as well. I think I want to change this corner down here a little bit and make it more consistent with this corner up here. So I'm going to select these points here and just move them down a little bit. And we probably have to adjust the handles again, but yeah, maybe move these down even a little bit further. So something like this. And I will tweak the tangents just a little bit, maybe just this one, see how that looks. Okay, that's looking nice, I think. So now let's delete the right half of our spline, And one easy way to get rid of the points without having to worry that the opening we need in order to be able to mirror this spline is in the right position, we can just disconnect the selected points and delete them. And now we have to delete these 2 points as well, and there we are. So now let's make a copy of our spline and rotate it. And of course we have to connect the 2 splines and then select these 2 points here and weld them together. And I'm going to close this spline, rename it to piece number 1, and let's do one final test to see how things are looking. So I think we can be happy with what we've got. It's a very nice looking shape. And in the next video we're going to take care of the protrusions on the other puzzle piece. So now let's finish the second puzzle piece. First of all, I'm going to make piece 1 invisible, and I'm going to switch on piece 2, and I'm also going to rotate the reference image 45 degrees, and we have to rotate the spline as well. So let's rotate it 45 degrees like so, and I'm going to reset the axis to 0. And now let's make a copy of our template. I'm going to make this editable, drag out another copy, and let's move this down. Oh, we should switch off enable axis first. So let's move this down to about here. And this one we have to rotate minus 180 degrees and then line it up with the reference image. And now I'm going to combine these 2 splines, and let's put piece number 2 into a spline mask object and drag our protrusions in there. So let's make the spline mask object editable and rename it to piece 2. And now we're going to do exactly the same thing that we did in the previous video in order to get our round corners. So I'm grabbing the line cut tool, and up here I'm going to make a cut from here to about here. I'm going to make this cut fairly close to the curve because I think the shape will just look a little nicer. So I don't want to follow the reference image, but rather create something that looks a little different. And like I said, I think it will look a little nicer if we continue this curve a little further before it transitions into the protrusion here. So let's select these 2 points, delete them, and let's tweak the tangents on these points here. So I'm using the pen tool again, lock tangent rotation is switched on, and I'm going to drag this tangent out a bit, and I'm going to drag this one out a bit. So now let's test the shape. I'm going to increase the detail of the spline. Let's see how that looks. I think the tangent down here could maybe be a little bit longer. Something like this. And I guess we could rotate these tangents up here just a tiny little bit to make that transition a little bit smoother. So this time I'm going to use lock tangent length and switch off lock tangent rotation. Let's rotate these tangents just a little bit, something like this maybe. Let's see how that looks. So I think that's looking pretty good. So now let's take care of the corner down here. And down here I'm going to make a cut from here to about here. Same procedure as before, delete these 2 points, grab these 2, and let's tweak those tangents. Okay, and that's looking pretty much the way I want it to look. I think I'm also going to rotate the tangents of this point like we did on the curve at the top of this piece. So let's switch on lock tangent length and just rotate these a tiny bit like so. Okay, so that's looking very good, I think. So next we're going to select the points on the right. I'm going to disconnect them and delete them. And let's delete these 2 points as well. And now we can make a copy of this piece and rotate it. And let's combine these 2 splines. And I'm going to select the points up here and weld them together. Make sure you close your spline. And now we can rotate it back minus 45 degrees. And I'm also going to rotate the reference image back to 0. And next I'm going to select piece 1 and piece 2 and use connect objects and delete to turn them into a single spline. And we can now use the MoGraph cloner, set the mode to radial. We need 4 copies and we don't need any radius, so let's reduce that to 0. And I'm going to make the cloner editable and combine all of these pieces into a single spline. So let's put the puzzle pieces into the extrude object, and we can get rid of this cloner null here. And that's looking pretty nice. So let's go ahead and add some fillet caps to the extrude object, and 5 is probably a bit much. You can see that the geometry is intersecting here, so I'm going to change that to 2. Yeah, well, that's still a bit much, so let's bring this down a little further. Let's maybe do 1.5, 1.6. That's looking better. And if you do a close-up render, you probably want to add 1 or 2 steps to those fillet caps here. And also the puzzle pieces right now are a bit thick, so I'm going to change the movement to maybe 10. That looks about right. Okay, so I think we're pretty much finished. Let's do one final render of this jigsaw puzzle in the front view. I'm going to use this view as the render view, and let's go to the render settings. I'm just going to increase the resolution of the image to maybe 1400. That should still fit on the screen if I render this to the picture viewer. So I think we have a pretty nice looking result here, and you can see that it was not that difficult to create this shape, and we didn't even have to spend a lot of time to do it. In the previous videos I showed you what I think was the easiest and most accurate way to create the jigsaw puzzle. Easy because we didn't have to do a lot of manual drawing or tracing or tweaking, and accurate because we were able to use parametric splines as a basis to create certain sections on our spline shape. However, I didn't want to conclude this tutorial without mentioning that by keeping things very easy, I also broke one of the basic rules. And that rule is that you should use as few points as possible to define your spline shape. One simple reason for that is because the fewer points you have, the easier it is to tweak your spline shape. Also, the more points you have on a spline, the heavier your spline gets. Of course, if you have a very complicated shape that has many curves and corners, you will need many points to define those curves and corners. But as far as our jigsaw puzzle is concerned, we could have done a few things differently and optimized the point count. So in this video I'm going to show you what we could have done better. And there's only two things really that we could have done differently. One is the template that we created for the openings and protrusions, and the other one is the gap spline we created. So we're going to start with the template. I will make this one editable and then go to point mode, and you can see that this spline shape has 7 points. Now, we didn't waste any points by creating this shape like we did, because we're getting a perfect circle. However, we could do this shape using only 5 points instead of 7. So let's go ahead and try and do that. I'm going to disconnect these 2 points here and delete them. And I'm going to delete these 2. And we can use our original template as a reference to tweak our optimized shape. So let's select these 2 points here, and I'm going to use the spline pen tool and switch on lock tangent rotations, and now we can tweak the tangents on these 2 points here. And you will see that we can get very close to the original circle. It's not going to be 100% perfect because we actually do need 3 points to get a perfect circle, but we can get close enough with only 2 points. So if I make a copy of the optimized version here, and I'm going to rotate it and combine these 2 splines, and now let's select these 2 points down here and weld them together, and I'm going to close this spline, and let's put this in an extrude object and render it. And you can see you can't really tell the difference to the original, so we're getting very close to a perfect circle. So this is one thing we could have optimized. The second object we could have done with fewer points is the gap spline. The one I did here already uses the optimized version of the template, and you can see that we only need 3 points to define this shape. Of course, if we create an outline, we get the problem that we had in the previous videos. We're not getting an even width along the spline length. However, instead of adding an additional anchor point, and by the way, in the original version we also should have added 1 more point at the tip of this curve to create an even more perfect outline, we can do this shape without adding any extra points. And it will not be completely perfect, but we can get very close to something that looks like the width is even. So what I'm going to do here is I'm going to select these 4 points and then again use the pen tool. Lock tangent rotation is switched on here, and we could make this tangent a little bit longer, and you can see we're already getting a fairly even shape. Of course, it's still a little bit wider up here and still not wide enough down here, so maybe let's tweak this tangent a bit and drag it down a bit further. And let's put this in an extrude object to test the shape. So it's still a bit wide up here, and we could do a little more tweaking. Maybe we could make this tangent a little bit longer, drag this one down a bit further, and maybe let's even change the rotation of this one a little bit. So you can see we can get pretty close to an even width. It's not going to be 100% perfect, like I said before, but we can get close enough to create the illusion, and we can save a lot of points. All the other steps for creating that spline shape are exactly the same as I showed you in the previous videos. So if you want to, go ahead and create your own optimized version. Now let's compare the original version with an optimized version that I did. So you can see we have the original on the right side and the optimized version on the left. If I do a render of these splines, and even if I get a lot closer to those puzzle pieces, the optimized version will still look pretty much the same as the original version. So let's compare the point count on the two splines. If I select the original spline, you can see we have 256 points here. The optimized version only has 160 points. So in this case, I think it would be worth spending the time trying to optimize this spline shape and get a point count that is a lot lower than the one on our original version. I hope you found this tutorial useful and you've learned a few things about creating spline shapes in Cinema 4D. Thanks everyone for watching these videos, and I'll see you again soon in another tutorial.